Okay, so this is chapter 5.3 CFU, and I believe this is concept 1 on conditional probability and independence. So the question goes like this: is there a relationship between gender and candy preference? Right? Suppose 200 high school students were asked to complete a survey about their favorite candies. So you have a table shown below, right? That shows the gender of each student and their favorite candy. So it's a two-way table. So one way we have the gender, and the other way of the table we have the type of candies, either Skittles or M&Ms. So define A to be the event that a randomly selected student is male. And event B is the event that a randomly selected student likes Skittles. So we're trying to see if event A and B are independent. Does event of choosing a selected student who is male, does that affect the probability, right, of event B happening, which is does choosing a male determine or affects whether the student likes certain type of candies? Does male like Skittles more, or does female likes M&Ms more? So this is how we can try to find out, are the two events A and B independent? Justify your answer. So to see if event A and B are independent or not, something needs to satisfy, and the condition is this, right? So you need probability of A has to be equals to probability of A given B, right? That stroke here, it's A given B, right? A given B. So B happens, and does A, then A happens. So if we're trying to see what's the probability, does B affect A, right? If B affects A, then they are not independent, right? If B doesn't affect A, then it is independent. So if A given B, we have to find the probability. So next thing we need to do is, what's the probability of event A? Now, the probability of event A, which is choosing a student that is male. So how many male altogether is 120 out of a possible how many students in total? 200. So its probability of event A happening is 120 divided by 200, which is 0.6. Now, next one is a little bit tricky. What is the probability of A given that B happens? Given probability that the student chosen, selected is male, that the student actually likes Skittles. So A given B, right? That's how it's being written as interpreted as A given B. So we highlight, or we draw the box of B. B is the probability that the student chosen likes Skittles. So this is the whole entire horizontal row. Now, of which, how many of those rows, how many of those numbers represent male? It's the 80, right? And in total, how many students like Skittles? 140. So probability of event A given B is 80 divided by 140, which is about 0.5714. So since the two probabilities, right? Probability of event A, which is selecting a student that is male, and probability of A given B, which is the probability of selecting a student that is male, given that this particular student likes Skittles. And those two probabilities are not the same. We can conclude, right? Well, it's being written that way. It's not equals to probability of A is not equals to probability of A given B is not equals to. Now we can conclude that event A and B are not independent. Now when they are equal, we can say A and B are independent. So independent just in a way it says that event A doesn't impact event B, or event B doesn't impact event A. So For event A and B to be independent, probabilities of event B does not impact, right? Does not impact nor influence the probability of event A happening. Okay, this is chapter 5.3, concept 2 on tree diagrams and conditional probability. So the question goes like this. A study of high school juniors in 3 districts, Salt Lake, Granite, and Canyon, was conducted to determine enrollment trends in AP classes, AP Calculus, or AP Statistics. So 42% of students in the study came from Salt Lake, 37% came from Granite, and the rest came from Canyon. In Salt Lake, 64% of the juniors took stats and the rest took calculus. 58% of the juniors in Granite and 49% of juniors in Canyon took statistics, while the rest took calculus in each district. No juniors took both statistics and calculus. Describe this situation using a tree diagram and find the probability that a randomly selected student in the study took stats. Okay, so since there are 3 districts, so we need to draw 3 separate branches, right? One for Salt Lake, one for Granite, and one for Canyon, right? SL stands for Salt Lake, G stands for Granite, and C stands for Canyon. Now, within each district, Salt Lake District, all right, the probability for students that are in the juniors in each district, it's broken down to 0.42, 0.37 for Granite, 0.21 for Canyon, 0.42 for Salt Lake. So let's look at the Salt Lake branch, right? Each branch should have 2 separate branches coming up from it, right? One goes to statistics. Salt Lake District's, the junior percentage is 0.64, and then the rest are taking calculus, 0.36. So you take 1, subtract away 0.64, you get 0.36. How about for Granite? Granite, for statistics, it's about 0.58, and the next branch, calculus, is 0.42. Same thing goes for Canyon. 49% took statistics and 0.51 took calculus, right? 51% took calculus, so we need to put it in decimal form. So the question asked us, what is the probability that the randomly selected student in the study took statistics? So we need to look at the branches that are saying that the students are taking statistics. So a statistics student could be from Salt Lake District, could be from Granite District, or could be from Canyon District. So first thing, we need to look at that branch. Now, when it's one branch after the next and they're connected, we multiply their probability. So it's 0.42 times 0.64. So that's the probability of a randomly selected student from the study who took statistics. And that particular result, 0.42 times 0.64, is the probability that a statistics student came from Salt Lake District. Then we need to look at Granite. So Granite, we need to add we don't need to multiply between the branches, but we have to multiply when the branches are connected. So we add now, right? The next branch will be from the Granite, students taking statistics who is from the Granite District. So it's 0.37 times 0.58 because these branches are connected. Now, is there another branch? Yes, we have another branch that comes from the Canyon District. So we have to add them. So Canyon is 0.21. I think I made a mistake there, which is not, that's supposed to be times. Okay, all right, 0.21 times 0.49. And when we do the multiplication and add them up, it's about 0.5863. C3. Okay, so we're going to continue to concept 3, but I'm going to keep the tree diagram because we're going to use the tree diagram to actually solve this following problem. So in concept 3, we're supposed to consider the situation from concept 2 and find the probability that the student picked from Salt Lake, given that this student is actually taking statistics. Okay, so I got slightly ahead of myself earlier. So yes, this is what we need to find. The probability of student is from Salt Lake, given that the student is actually taking statistics. So this is actually a conditional probability, right? A condition probability, they specify an event. Now, when that event happens, what is the probability of that following event? So I want to just kind of briefly go through the symbol. So we write P, right, probability of A with the vertical straight line down, then given by B. So this is actually asking you what's the probability of event A happening given that B happens. Okay, and the formula is, the conditional probability for this is probability of A intersect B, right? Intersect means N, divided by probability of B. So that symbol N, inverted U, it means intersect. So what's common between event A and event B, right? Intersect, or N, right? And what we do is we look at the tree diagram and we multiply along the tree branches, right, for that to happen. So let's go back to a question. Probability student is from Salt Lake, given that the student took statistics. So if we write according to the conditional probability formula, so it's probability of Salt Lake, student from Salt Lake, intersect, or N, right, that the student is taking statistics, divided by probability that student takes statistics. So you follow the tree diagram, which I've just kind of highlighted. It's 0.42 from Salt Lake times probability that the student is taking statistics, 0.64, divided by 0.5863. And this was from our previous concept 2 problem, which we got the answer from. So the answer is 0.4585.